Welcome to Programming Languages at Riga Business School. I assume most everyone has seen me before and has taken a course with me before, but just in case, I am Valdis Saulsperants. My email is here if you need to contact me in any time in the future. And so this is a course BBM 774. Alright, so what are we going to be doing here in this course is we're going to learn a concept of programming language. And again, some of you already have seen, okay, pretty much all of you have programming experience. You probably have Python experience, you have C++ experience, maybe you have JavaScript experience, maybe some other languages, maybe Rust already, maybe something else, right? We will learn this maybe a little more formal way. And also we will discuss and learn how different program description paradigms are used. Imperative, which is probably the most common one, functional, logic, which is probably logical, less used, maybe declarative, also slightly related to logical ones actually, but also maybe less used, and of course, very popular object-oriented approach. Again, C++ is a major example of that, and of course, what's actually is happening these days in most languages, most modern languages, it's actually a hybrid approach. For example, Python, you can write imperative code, you can write functional code, you can write object-oriented code. All right, so I think we should start with the grading. Again, this is nothing new for most of you who've taken courses with me. It's 30% will be these weekly quizzes plus participation points possibly for some extra, maybe some extra assignments. Again, maybe if you are active in a class. So that's 30% of the grade. There will be a midterm in the middle around week 7 or 8, 30% of the grade. Again, it will be open book, all tools allowed except live human assistants. Live AI assistants will be allowed, but I will warn you already that some of these languages, some of the tools you'll be using, AI will not be as useful. Maybe it will be slightly useful, but not completely. So you will still need to study for sure. Okay, and as this course will have 7 major topics, so there will be 7 sort of say, relatively big assignments. And so those will make 40% of the grade, and this will lead to your automatic grade offer, so no exam required. And again, very usual for my courses, there will be an optional extra credit assignment. You can raise the grade by 1 point by writing something on some language which we do not cover in the class, right? So we talk about Rust. I don't want to see a presentation on Rust, for example, right? But maybe Ruby, maybe Lua, maybe, I don't know, Swift, pretty much any modern or actually maybe esoteric language. I mean, I've had people write some esoteric language such as, of course, Brain F language and other languages. All right, so what are we going to actually cover in the course, right? So just general introduction, right, which is today, basically, syntax and semantics, and this is probably the more formal one. We'll talk how languages are actually described using BNF, eBNF, syntax diagrams, things like that. And here we will talk about Go, which is an imperative language, functional language, Clojure, which is basically a Lisp, or you call it a better Lisp, a very, maybe not very often seen in a practice language, but actually still very influential language. Prolog can be still used. And maybe the one language you might have some experience in other courses a little bit, which is the classical declarative programming language, SQL, where we actually, we describe the rules. Actually, of course, for database access, for relational database, structured query language. We'll cover that for a week or two. And then we'll also talk about Kotlin, which is basically a better Java, and a hybrid language such as Rust, which is better C++ or Scala. Again, basically, in making this course, I adjusted these topics to mostly focus on things which are actually useful. I know, of course, academic learning is oriented toward completely theoretical topics, right? But so out of this, Go, Clojure, SQL, Kotlin, and Rust are all languages you can use in practice, in production, not only in academical setting. Prolog and BNF, probably not so practical, but You would need to know, again, even if you don't want to be a programmer completely full time, still will encounter some concepts that might be useful. Also, I should mention this order: Go is towards the end, Rust is the last. I think Go I move towards after Kotlin, actually, right? We'll start with EBNF, right, and move on. All right, so now the question is, where do we get the course materials? And this will be the primary area. The books are not really necessary because books are very general, unless of course you get a language specific book, right? That would be useful. Now let's go briefly into the GitHub repository. I believe this should still be live. Let's take a look. And in fact, I believe I still have it right here. And yes, the link is okay. And there is a file called resources.md, right, which will show you some learning resource, just a start. And funny enough, Wikipedia is probably best resource on BNF for starting, because some of the standard documentation is kind of boring, actually, right? But there's some other things. We'll have some other materials. And again, none of this is required, but these are just a good, useful start. Some important, some, I would say most of it is useful, most of it, right? And some of them, if you have some useful resource, we will add some extra resource as the course goes. Again, as usual, modern languages are fluid, things change, just like web, of course, changes, so some more resource might be added during the course. All right, so that covers basic introduction. And in a next video, we will look at actually an overview of programming languages, just sort of big landscape, before moving on to history for next Thursday's lecture. All right, thank you, and we will continue shortly in the next lecture.